Alright, so our second question on this exam looks at the difference between enantiomers, diastereomers, constitutional isomers in the same compound. And so if we start with part A here, the first thing that should get our attention is that we have a bromine here. And we can see in one case it's pointing forward, and in one case it's pointing back. If we determine the stereochemistry here, we'll see it's R, and we'll see it's S over here. Now we also have this center, which appears to be the same on both compounds. But notice at that center that two of the substituents, methyl groups, are the same. That means this is not chiral. And so this molecule only has one chiral center. Since that chiral center has been reversed from one compound to the other, that makes these two compounds enantiomers. In part B, we actually have two chiral centers. And as we can see, the chiral centers have both been reversed from the compound on the left to the compound on the right. So initially we might say that these are enantiomers. But we want to be very, very careful here, because both of these compounds have an internal plane of symmetry. Because they have that internal plane of symmetry, these are meso compounds, which means that in fact they're not chiral at all, and they are therefore the exact same compound. Part C is one that can be a little bit more challenging. Why is that? Well, there's no stereocenters in either molecule. And so this is one where you'd really be best served by putting together models for both compounds. Now, if you do that, what you'll find is that because of this very specific functionality, this is known as an allene. An allene is when we have a carbon that has two double bonds. But what happens with an allene is, because you have to use different p orbitals to make the double bonds, given that the middle carbon is part of two different double bonds, is going to have to use two p orbitals. The two double bonds will actually be at 90 degrees to each other. And so the shape of one of these molecules often looks more like this. And so if you put models of both of these together, you find that in fact allenes can be chiral. And if they have four different substituents, in fact they are chiral. And so these two molecules here are mirror images that are not superimposable or enantiomers. Finally, in part D, these are the same compound. Why? Well, we have an OH, we have an H, but the rest of the substituents around here are just the rest of the ring. And given that the ring doesn't have any additional substituents, those two substituents are going to be the same, so we don't have a chiral center, and therefore these molecules are not chiral, and they are the same.